Recently I heard about some open source firmware that was available which can be loaded onto a flight controller and ultimately become an autopilot for a quadcopter, model airplane, or nearly any other remote controlled air, land, or water-based vehicle. I was intrigued by this because several years ago I had considered using a weather balloon to lift a remote controlled glider to a high altitude, then release it and have the glider fly itself back home. At that time, writing the code for the processor to accomplish that task seemed a little beyond my abilities. But now it seemed that somebody had taken care of the hard part for me. So, I decided to purchase a reasonably priced quadcopter kit and experiment a little with what was available. Hi everyone and welcome back. This is the quad that I decided on. It's the QAV250 by Holybro. This is the flight controller. This one happens to be the Pixhawk 4 Mini. This is where the firmware gets loaded that allows you to configure all the parameters for everything from manual flight control from a standard RC transmitter to completely automated flight based on waypoints that you assign it. The firmware that I am currently experimenting with is called PX4. Today I thought I would run you through the process that I went through to create a waypoint mission for one of my first autonomous flights. The software that I'll be using is QGroundcontrol. It's not only used for configuration, it's also used to monitor any telemetry that you can send to it via radio from the flight controller. One of the purposes of this test flight is to make sure that I have resolved the issues that I had with the telemetry radio was causing interference to the GPS receiver. It was so bad that the GPS could not get a fix and would not allow me to arm the flight controller. And if you can't arm the flight controller, then you can't fly. So I'm hoping to find out that I have resolved the interference problem and that it has decent enough range that I can be able to receive the telemetry non-stop. So I believe the issue that I had found is this little guy. A poorly manufactured antenna from an inexpensive product. The telemetry radio is right here. This antenna screws onto the end here like so, and I believe it's a bad enough antenna that it was just allowing too much radio frequency interference to the GPS receiver, which is located here. My resolution, after a lot of research and not really finding any concrete solutions, was to build a dipole antenna, which a little homemade guy that I've done here. I took an old cable that had the correct connector on it, split it out, cut it to the right length for the frequency that I'm using, and we'll see how it works. So, with that being said, let's start creating that waypoint mission. So this is the planning screen in QGroundcontrol. The first thing you need to do is select a takeoff point, so you click on takeoff and then click on the map where you want that point to be. There's a few extra parameters that you can use to tell it what altitude and what heading you may want to pursue during the flight. After that, you click on a waypoint and then click on the map where you want that waypoint to be, and it draws a line from the takeoff point to that waypoint, and from this point forward, each time that you click on the map after selecting waypoint, it will create a new waypoint in the file. Each waypoint has a few parameters that you can adjust for altitude. If you want to hold in that particular position for a number of seconds, the yaw of the vehicle, which is only selectable in multi-copter mode. If you're in airplane mode, well, you obviously can't yaw the airplane to a different direction other than what you're flying in. The flight speed can also be adjusted. Otherwise, if you don't change either one of the yaw parameters or the flight speed, then it will use the program defaults. Now I'm still sort of climbing the learning curve on this software, so there's a lot of things about it that I'm not aware of, and sometimes you find out the hard way. My original intention with this flight was to start at a lower altitude, climb to about 150 feet, and then on the return trip, reduce the altitude back down to around 50 and possibly 20 feet before coming back in to land. Well, I had most of those parameters all recorded, saved, and loaded into the flight controller, and then made kind of a newbie error when it came time to fly the course. I plugged back into the flight controller and decided to go with the default speed, and there was some confusion between metric units and standard units, and I got a little bit of a surprise when the flight first started. So you'll get a chance to see that, at least from the onboard camera. But basically, that's all it takes to create a Waypoint mission. You load it into the flight controller, you can save it as a file for later use, and that's about it.
Armed. Mission flight mode.
It was at this point that I realized something was not as I had intended. The quadcopter pitched forward at about a 30-degree angle and sped off down the river. Now, I had originally set the maximum speed for the flight at around 10 miles an hour. It was clearly going much faster than that, and it was making a noise I had never heard before. I started to get a little excited. My first thought was that maybe a propeller had come loose, but it seemed to be flying okay. It didn't take me too long to figure out what was going on. I had been verifying some of the mission settings prior to the flight, and in doing so, I had clicked the default button for maximum speed. Apparently, the number 10 that I had punched in for the default setting was in meters per second, not miles per hour. 10 meters per second equates to about 22 miles an hour. This was about twice as fast as I was planning on, but it was doing just what I had told it to do. As for the strange noise, well, I had a piece of tape over the receiver as a safety measure to keep it from sliding out of the quadcopter during the flight, and at that speed it was fluttering in the wind and making a lot of noise, and making me very nervous. Those little jerks in the camera that you see at different points along the flight happen when it reaches one of its waypoints and makes a slight turn. Unfortunately, the camera I'm using on board doesn't have a gimbal or anything to keep it steady, so any movement is very noticeable. I'm going to try to find the settings for the yaw axis and see if I can tune out those abrupt changes, maybe make the video a little more stable. This was my third Waypoint mission flight, and each time I learned something new. I'm trying to learn as much as I can about the capabilities of this flight controller firmware so that I can use it on some future projects. So all in all, the flight went well and was totally hands-off from the time that I put the flight controller into mission mode. I think for one of my next videos, I'm going to talk about one of my past projects that started nearly 20 years ago. If you like this video, please click on the old thumbs up icon, and if you'd like to see more, please consider subscribing to my channel. Thanks again for watching, and we'll see you next time.